Hi everyone. In this lecture we are going to discuss the trigonometric circle and the angle measurement in the circle. Before starting, we must discuss what is an angle. So basically an angle is the rotation of x-axis along its mean position. Suppose if we rotate it like quarter of a circle, our angle will be of 90 degree. If we rotate it half of the circle, our angle will be of 180 degree. If we rotate it three-quarter of the circle, our angle will be 270 degree. And if we complete the whole revolution of the circle, our angle will be 360 degree. So when we complete the whole revolution of the x-axis, we find a circle. And a circle is like a wheel, we can rotate as many times as we want. After completing the first revolution, we will be having an angle of 360 degree, and when we move further we will have an angle of 361 degree, 362 degree, 363 degree. When we complete the second revolution, we will be having an angle of 720 degree, and if we complete the third revolution, we will be having an angle of 1080 degree, and so on. So we can say that we can have an angle of infinity. The rotation that we have discussed here is in anti-clockwise, and the angle is considered to be a positive angle. So here we have a positive angle of 30, 45, 60, 90, 120 degree. But if we change the direction, then we will be having a negative angle. Means if we rotate the x-axis clockwise, we will be having a negative angle. So this will become a negative 30, negative 45, negative 60. Here where we have 270 degree, in anti-clockwise we have a negative of 90 degree, and here this is negative of 180 degree. That is the connection here. So likewise, when we change the direction, we will get a negative angle. So we can say that our angle can take any value from negative infinity to positive infinity. As this circle behaves like a wheel, we can rotate it to infinity in any direction. Degrees and radian. Earlier the measurement that we have used is degree measurement, and now we will discuss radian measurement. In radian measurement, angle is the ratio of length of arc of rotation and radius of the circle. While in degree measurement, 1 degree is 360th fraction of the revolution or the rotation. Here we have a unit circle, means a circle whose radius is equals to 1 unit. We are at A and we are rotating to B, that is length of the arc. So theta is equals to AB over OA. So when we rotate or when we complete the whole circle, the length of arc will be the circumference of the circle, that will be equals to 2 pi r. In this case we have a radius of 1 unit, so the circumference will be equals to 2 pi. And in unit circle, the angle, or we can say that the angle is equals to the length of arc only. So here angle will be equals to 2 pi radian, and we denote it by C. So let's start from point A and move anti-clockwise. We have already discussed the movement in clockwise and anti-clockwise direction. So if theta is equals to 0, means the length of arc is 0. If theta is equals to 360 degree, means we have completed the revolution. So the length of arc will be equals to the circumference of the circle, and that will be equals to 2 pi. If theta is equals to 180, this means that we are completing only half of the circle, means we will be having a circumference of pi unit. And when theta is equals to 90 degree, so the length of arc will be equals to pi by 2d. As we discussed, if we have a unit circle, means the length of arc is equals to the angle. This means that when theta is equals to 0 degree, it will be equals to 0 radian. When theta is equals to 90 degree, we will be having of an angle of pi by 2 radian. When theta is equals to 180 degree, we will be having a pi radian. And when theta is equals to 360 degree, then the angle is equals to 2 pi radian. So as we discussed, we can say that 360 degree equals to 2 pi, or we have already discussed that pi is equals to 180 degree. In the left hand side of the equation, we have a radian value, and in the right side of the equation we have a degree value. So by interchanging, we can say that the ratio of degree and radian is equals to 80 over pi. We can use this relation to change radian measurement into degree measurement. Suppose we have an angle in degree that is equals to 90 degree. Suppose we have a theta of 90 degree and we want to convert into radian measurement, we can put it here. So it will have an angle of x degree in radian. Let's put these value into the relation. We will be having 90 over x is equals to 180 over pi. By transposing x to the right side, we will be having x is equals to 90 pi over 180. 0 cancel, it is that 9 times 2 is 18. We will be having x is equals to pi by 2. So we can say that when angle is of 90 degree, it can be considered as pi by 2 radian. So here are some basic angles that we will be using into the further classes or in the further chapters, and their relation in degrees and radian. Each angle is denoted here or represented here in both form, degree and radian measurement. Like here 60 degree can be represented, or we can write it like pi by 3 in radian. 45 degree is equals to pi by 4, 30 degree is equals to pi by 6, and so on. We have three angles, theta 1, theta 2 and theta 3. Theta 1 equals to 30 degree, theta 2 equals to 80 degree, and theta 3 is equals to 27 degree. We have to convert this into radian. This means that we have a relation that we have discussed earlier. Ratio of degree and radian measurement is equals to 180 over pi. Let's put this value here. We have a degree measurement, so we'll put that in place of degree measurement, and suppose it will be having x radian. So 30 degree by x will be equals to 180 by pi. By transposing this x to the right, we will be having x is equals to 30 pi over 180. 30 times 6 is 180, so x will be equals to pi by 6, or we can say that 30 degree is equals to pi by 6. Second angle that we have is of 80 degree. Let's change it into radian. So suppose 80 degree is equals to y radian. It should satisfy the relation degree over radian equals to 180 over pi. We have an angle of 80 degrees, so we will be putting that here. 80 over y will be equals to 180 by pi. Transposing this y to the right side, we will be having pi, y is equals to 80 pi over 180. Okay, 0 will cancel each other. 2 times 4 is 8, 2 times 9 is 18. These two have a common factor 2, we can cancel them. So y will be equals to 4 pi by 9. So the third angle that we have is 27 degrees. Suppose that is equals to z radian. So the relation will be 27 over z equals to 180 over pi. By transposing this z to the right, z will be equals to 27 pi by 180. 9 times 3 is 27 and 9 times 20 is 180. So we can say that z is equals to 3 pi over 20. So 27 degree is equals to 3 pi by 20 radian. Let's have a look on another example. Here we are given angle in radian measurement and we have to convert it into degree measurement. So we will be using the same relation, degree over radian is equals to 180 over pi. In the first question we have an angle of pi by 3 radian. Suppose pi by 3 radian is equals to x degree. So these two must satisfy the relation. So x over pi by 3 will be equals to 180 over pi. Pi and pi will cancel each other. So it will be x is equals to 180 over 3 and this 3 will cancel 180 in 60 times. So x will be equals to 60 degrees. So we can say that pi by 3 is equals to 60 degree. Likewise, we can consider the second angle theta 2 that is equals to 4 pi by 9 as y degree equals to y degree. Then our relation will be y over 4 pi by 9 is equals to 180 over pi. Pi and pi cancel each other and y will be equals to 180 into 4 by 9. This 9 will cancel 180 in 20 times, so y will be equals to 80 degree. And the third one, we have an angle of 2 radian. Suppose this 2 radian will be equals to z degree, and putting these z and 2 radian into the relation, we will be having z by 2 equals to 180 over pi. So z will be equals to 360 over pi, and putting the value of pi, that is equals to 22 by 7 into the equation, we will be having 360 by 22 times 7. So it will be equals to 114.5. Hope radian and degree measurement are clear to you and you can easily use this concept into your exams.